I had a dream this morning. And yes, it was this morning because I woke up around 8 in the morning to let my dog outside to pee, and then I went back to bed. I had a dream this morning where, of all things, what I was doing was I was putting into ChatGPT a hypothetical, like, so I have feelings for this person, and I was putting in this and that reason why it wouldn't work. And then ChatGPT was replying, why not do this? Why not do that? So I kept on replying, I can't do this because this is the reason this wouldn't work out or what have you. And even in my dream, ChatGPT replied, yikes. And then one of the replies was, have you considered Reddit? So I'm thinking, like, what's Reddit got to do with this? What can Reddit do? And then I realized, oh, ChatGPT is recommending I post on Reddit and ask Reddit what to do here. I don't know, it was just a silly, stupid dream I had. Anyways, so I swear to you guys, I'm not kidding to you guys when I say that today I planned for it to be a study day. I really did. I didn't even bring my Switch out with me today to game and distract me. I was really dedicated, or I was really set on today being just a study day. Because I have a paper due tomorrow, I'm only barely halfway through week 1's material, and I still have week 2 materials I haven't even gone through yet, and I have a paper due tomorrow. So, no dilly-dallying. Today we're just gonna study. Today I'm just gonna go over the material. Only the material. Hopefully tonight I finished all the material, all of week 1's and 2's, hopefully, and then tomorrow I just work on the paper. Technically, you know, the online what have you says there's no time limit for handing in the paper, but the course timeline says due tomorrow. So, yeah, I'm kind of screwed. Look at me, all these years and I've still learned nothing. All these years and I still do the same thing. I procrastinate to the very last moment. Nothing has changed. It's a miracle I even graduated college the first time. But before we get on with that, so let me continue to say that today, like I said, I did plan for it to be a study day. And then I realized, oh shit, today was Shadow Raikou Raid Day in Pokemon Go. Oops. So of course I did that, because that was more important to me. I did, I think, 12 raids on my phone, and 6 raids on my sister's phone. Not a single one shiny. The best IV one I got was like a 93 IV, I forget. I think it was either a 14, 13, 15 or a 15, 13, 14. I'm pretty sure the second one was 13, but whatever. And on my sister's phone, I did get a double XL Shadow Raikou, but nothing good. No hundos, no shinies, waste of my time. So because instead of studying all day like I genuinely was expecting to, I spent all day doing Raikou raids. What a waste, because not even a single shiny. Okay, enough dilly-dallying, let's get onto it. So let's see, last time, I actually was going to read the rest of week 1's material today on my own and then just jump into week 2. But clearly that's not how things played out, so I'm just gonna read the rest of week 1's materials. Just a quick glance, there's not too much. Okay, thank God. Thankfully, week 1 materials, there's not too much left. Okay, so the last time I did read the longest chunk, so let's move on. Alright, sometimes it may be difficult to find where the service entrance is located, especially when the basement space is finished. Piping identification. Most of the water service piping is not visible. In some cases, it can be seen at its point of entry into the building. In warm climates, it may be seen coming out of the ground and into the building above grade from the outside. In some cases, the surface piping is visible at the meter outside the house. Warm climates only, in bracket. In cold climates, the meter is typically inside the house. By the way, I double-checked my course timeline today, and I almost had that sinking feeling like I am so screwed before I even started. Because I realized there is a ton of material. Like a ton of material. And I'm not even done one. And I was thinking, oh shit, was I supposed to study one material of each topic per week? I double-checked the course timeline. No, thankfully what I've been doing is correct. As correct as it can be. So it is one slide, one PowerPoint presentation slides per week, not one per subject per week. Thank God for that. So yeah, if that was the case, then I probably would have just quit altogether. Be like, alright, well, I already give up. It's only 2 weeks in and I already give up. Alright, copper is the most common. Service piping when different types were used. And there's a diagram here. PEX started to be used in North America as PB failures were reported. It became popular around 1995. So copper is the most common. Chart in study session 4-6.0, whatever that means, summarizes material properties. Material, color, connections, when used, texture, flexibility, strengths, and weaknesses. Alright, separate water service from sewer pipe, and there's a diagram here. Water service piping in trenches. Water service piping must be buried at least 12 inches. In areas of frost, the piping must be taken... excuse me. The piping must be at least 12 inches below the depth of frost. Speaking of frost... oh yeah, there was that too. I really did... the moment I got to work, I did open the computer and start looking at my notes. I really did. But then I got a phone call saying that my dad's car kind of broke down in the dead of winter. Like he was sending a job close by, like a 2-minute drive away, so it wasn't that far. But then I got a call saying that his car just wouldn't start. So I had to drive over and then spend like the next hour trying to help him fix his car. One of my dad's friends showed up. We ended up needing to use some jumper cables to jumpstart his car. It seems fine now, but you know, it was very cold outside. And in fact, tonight, starting around tonight, quote unquote, around like 7 a.m., there's going to be a huge winter storm happening. Folks, I don't know if I'm just getting old or not, but this winter in particular has been something else. This winter has been exceptionally cold. And I'm someone who likes the cold, and even I'm saying it's very cold. Anyways, let's get going. Supply pipe separate from sewer pipe. A water service pipe and a sewer pipe should not be laid in the same trench unless the water service pipe is at least 12 inches above the sewer pipe. Bracket, 20 inches in some jurisdictions. The service pipe should be fully supported on a shelf at the side of the trench. Some jurisdictions call for 5 to 8 feet of separation between the water service pipe and the sewer pipe, although they will often accept the 12 to 20 inch rule elevation difference between the sewer and water service pipe. The water service pipe should be fully supported on the shelf over its entire length. While good to know, this is not something we can inspect. New copper entrance from the street. Depth of evacuation. What? Depth of evacuation depends on the frost level in the local area. And it shows a picture of what it looks like. Another picture. Obsolete pipe and new plastic water supply pipe. New plastic supply pipe. Note the old abandoned supply pipe next to the foundation. This new service pipe may be prone to mechanical damage. Ideally, some type of enclosure should be provided. Another disgusting diagram. An old service pipe with a stop and waste valve. That's what the picture is. Another one. Feeding a sprinkler system? Question mark. Service pipe, shut-off valve. Here's an exterior service entrance. Only suitable for warm climates. Yo, buddy, I'm screwed. I have a paper due tomorrow, and I'm just now finishing week 1's material. I haven't even touched week 2's, and I need that knowledge for the paper due tomorrow. Soil has been dug out to expose the shut-off valve on this copper service. This is more ideal since the valve isn't exposed to soil. Damn it, I want a game! I got shows to watch, but I got this to do instead. This is a copper service pipe, just a picture. There is a meter on this copper service pipe. Note the style of shut-off valve. The grind never ends. Well, it technically does once you're done school, but I, for some stupid reason, decided to come back to it. The bend in this pipe suggests that this is a lead service line. You ever notice that the pipes inside your house always look nasty, disgusting, you never want to go close to it, let alone touch it or inspect it? And they're always in the most gross corners of the house. Here is a copper pipe that has been crimped. This is likely due to mechanical damage during or subsequent to installation. This will, of course, reduce the water flow and effective pressure in the home. Recommend repair. Because this is not an immediate concern, but only affects the quality of water pressure and flow. Time frame for repair can be discretionary. Jesus. There is, however, another issue in this photo. The green corrosion is likely the result of direct contact between the copper pipe and the concrete. The pipe should have been protected by some type of insulating material, typically a plastic sleeve. The pipe will be prone to premature leaking. Alright. Here's a main shutoff valve that is leaking. The evidence is the bucket just under the valve. Check the active leaking and recommend repair. The implications of leaking shutoff valve are water damage and perhaps rust forming on the valve, rendering it inoperable over time. If the leak is severe, the water flow and pressure in the house may suffer. In some localities, this valve is illegal for a main shutoff. First, it's not a full bore value, whatever bore means, B-O-R-E. I never heard bore value before. First, it's not a full bore value, and it's a stop and waste. Yes? Yes? Sorry, I just had to reply to my mom, asking if I turned the stove off or not. Full bore is required for volume and pressure reasons. The issue with stop and waste when installed in area where it can become submerged or, after draining. Contaminants can be pulled in through the waste. Alright, another picture. If you look closely, you can see a lot of rust on this valve. Valves may rust because the valve is or has been leaking. The valve or piping is or has been sweating. The environment is extremely damp. The valve is partially buried in damp soil. Those are the reasons. Rusted valves may be inoperable or leak badly when operated. That's a weird sentence. Never turn valves on or off, especially a rusty one. If it breaks and or leaks, it's because you touched it! Exclamation point. At least according to the homeowner. Problems with service pipes. Low pressure. Pipe size, water meter, corrosion, city valves, obstructions, corrosion, crimps, etc. Leaks. Corrosion, settlement, mechanical damage, splitting, connection failure, freezing, or mechanical damage. Heaving, settlement, poor installation, careless landscaping, or storage. Causes are sub-bulleted in the slide above. I should have read that sentence first. Okay, shut-off valves. Alright, there's globe valve, gate valve, or ball valve. General problems with valves. Missing or cannot be located. Leaking. Inoperable. Inaccessible. Buried. Damaged handle. Partly closed. Exposed to mechanical damage. Rusted. Inspectors do not operate valves because they are not used to regularly... What? Because they are not used regularly, they can be prone to leaks or damage. Alright, main shutoff valve, stop and waste. Stop and waste valves are not full bore valves. They are not common on new installations and are not permitted in all jurisdictions. These should be used where the valve may become submerged since the waste creates a potential cross connection. And then a diagram of a water boiler. Stop waste valve has bleed valve downstream of valve, bracket for draining water out of the supply pipes for repairs. Anyways, stop and waste valves. Many shut-off valves are stop and waste valves. This means that there is a bleed or drain valve on the downstream, bracket house, side of the valve. The purpose of the stop and waste valve is to drain all the water out of the supply piping, for example, if the house is to be winterized. On some old valves, the bleed valve operates automatically when the valve is closed. In more modern stop and waste valves, there is a cap on the bleed valve that allows you to decide whether or not water is going to bleed out of the pipe downstream. Speaking of bleed, yeah, that's still happening. So I need more water. There's a picture here of what looks like a doorknob on a pipe used to throttle water flow. Anyways, globe valves tend to be restrictive but can be used to throttle water flow. Kinda doesn't seem like an effective... Actually, you know what? Now that I look at the diagram, never mind. That kinda makes sense. At least seeing the cross-section. I'm not sure what happened there. Well, actually I do. My phone died. Despite it being plugged in as well. Sometimes when... you know how cords are. Sometimes when you use them for too long, they kinda... don't work all the time. So you have to plug it in all the time to see when it will work. Anyway, so it's been a couple minutes. Actually, it's been quite a lot of minutes. I went and took care of something. Because I'm not going to have time to do it after this, so I went ahead and got that done now, but whatever. So, let's continue. It's now 10:20 p.m. I'm not exactly sure where I was cut off, but it doesn't really matter. Anyway, so continuing, this main shutoff here is using a gate valve. Okay. Ball valve. Full bore valve used for mains and water heater. Okay. Ball valves are less restrictive to flow than other valves. The handle position gives a clear indication of whether the valve is open or closed. Okay, shut-off valves. Conditions: missing, leaking, inoperable, damaged handle, partly closed, exposed to mechanical damage, or rusted. Case study 1. Component: shut-off valve on a copper surface. Condition: valve buried in soil and difficult to access. Implication: rust, premature failure due to soil contact and moisture. Recommendation: remove some soil to provide access to the valve. Oh, that was it. That was it, and that's all of week 1's material. Now to week 2, and then I will be equipped to do my paper tomorrow. That was all of week 1's material, and it only took me a week after basically week 2 to get through it. I am a failure in life. Okay, so I don't have week 2 materials downloaded yet. I actually have to log back in, which is a huge headache on its own. Accessing the goddamn material is alone quite a headache. Oh no. Hold on. Okay, oh. Well, that was stupid. That was very stupid. Just gonna move on. Man, there's this new thing now when signing into email. You need to download an app on your phone to authenticate your logging in. It's an extra layer of protection, sure, but it's annoying. You know, it's kind of interesting. I don't know why it's written like this. It's written like this for everything. Never mind, not the second one. Oops, don't do that. Okay, never mind. It's literally only written for this. So everything I read out, it's titled Module 1,3. And then, so that's week 1's material, comma 1-3 dash. How much battery do you have? Let me see. At the moment, 39%. But it's charging. But yeah, it's funny how this first one is worded. The first PowerPoint is module 1,3. Module 2 is just 2. And then module 3 is 4 and 5. Whatever. Okay, this one's a little bit better. I see a lot more pictures. Yay, less reading. And it's only 64 slides instead of the 70. Oh my god, and I see, oh my god, there's so much to read. Okay, that one slide had a lot to read. Okay, a second slide with lots to read. You know, everything I'm seeing looks like it's stuff that comes out of back rooms. Very industrial, very old-timey looking pictures. Very nasty looking. Very liminal, too. Okay, just a quick glance. Not too much to read. Only a handful of slides that have a lot to read. Okay, let's get started with Week 2 materials on literally the last day. Before my paper is due tomorrow. Okay, private water source. Private water sources most often consist of a pump and water source. Source of water from a well, lake, river, or cistern. Evaluation of water quality and quantity, not in the scope of a home inspection. Water quantity is important to determine the capacity of a well system, amount of water available, and the recovery rate of the well. Okay, private water sources are most often... Private water sources most often consist of a pump and source of water such as a well, river, lake, or cistern. Before we discuss these further, let's clarify our position in water quality and water quantity. Water quality and quantity. The evaluation of both water quality and quantity is beyond the scope of a home inspection. The water quality can be checked by sending a sample of the water to a laboratory. The water sample typically has to arrive in the laboratory quickly to ensure a good test. Tests for E. coli and coliform bacteria are common and rudimentary items for a quality check. The water can also be checked for impurities such as minerals, chemicals, and slit. Water samples should be taken upstream of any water conditioning equipment to test the actual raw water. Water conditioning equipment may improve the water quality, and you may want to test this as well. Alright, odors and cloudy water. While home inspectors don't typically check quality, you may be criticized if you don't notice that there is a strong odor emitting from the water or that the water is very dirty or cloudy. Many home inspectors recommend further investigation if an odor or cloudiness are detected. Oh my, very much to read here. And this is only slide number 4. Drawdown test. If the greater amount of drawdown... What? No, there's no if there. The greater amount of drawdown, the lower the capacity of the well. Hold on, let me just look at something real quick. Okay, anyways. A recovery test measures how quickly the water level in the well returns to normal after the drawdown test is finished. A recovery rate of 3 gallons per minute is considered acceptable in many areas. The speed at which the water level is drawn down during the test provides some idea about the amount of water available. The recovery rate indicates how quickly the water is replenished. A recovery rate of 3 GPM is considered acceptable. Seasonal variations may occur. Alright, water quality. This is a lot to read. Very, very much. It can be very difficult to know how much water is available at a property. It's fairly easy to determine the flow rate available from a single faucet by seeing how long it takes to fill 1 gallon container. For example, if it takes 20 seconds to deliver a gallon of water, we know we have a flow rate of 3 gallons per minute. What we don't know is whether we have this flow rate available to us all year long. We also don't know if we can maintain this flow rate for 15 minutes, for example. Obviously, flowing water at a rate of 3 gallons per minute for 60 minutes would require a supply of 180 gallons. So the drawdown test. A well drawdown test can determine, to some extent, the capacity of a well system. A plumber would perform a well drawdown test by disconnecting the house water system and pumping water out of the well at a given rate over a period of time, often several hours. As the water is flowing, the level of water in the well is monitored. If the water supply is strong, the well will be replenished by the groundwater quickly, and the water level in the well will not drop dramatically. It's common for the water level to drop somewhat during a well-drawn-down test. The speed at which the water level is drawn down during the test provides some idea of the amount of water available. Without measuring the water level in the well as the test is performed, you can't learn very much about the quantity of the water available. For example, you may run water at a rate of 3 GPM for 60 minutes and find that you have 180 gallons of water available. However, as you turn off the tap, the well may be very nearly dry, and it may take a long time for the level in the well to recover. Shortly after you finish your inspection, the homeowners may run out of water. Recovery test. The well recovery rate is often measured as part of the drawdown test. This indicates how quickly the water is replenished and is determined by measuring the rate at which the water level rises after drawdown. A recovery rate of 3 gallons per minute is considered acceptable in many areas. Recovery rates are not always uniform and are often an average number. Seasonal variations. Even a well-performed drawdown and recovery test cannot tell you everything you would like to know about the quantity of water available to the home. A good result from a test in May won't tell us how much water is available in September. Groundwater levels fluctuate with the seasons and the amount of rainfall and/or snowmelt, if applicable. New homeowners have a tough time knowing the overall water supply situation. Ooh, speaking of water, history is useful. Areas tend to have water supply characteristics. Asking questions of the present homeowner, neighbors, municipal or rural officials, and real estate professionals may provide some insight as to the probable adequacy of water supply. This research goes beyond the standard home inspection. What kind of flow rate is acceptable? Generally speaking, a flow rate of 5 GPM that can be maintained over time can be considered good. A flow rate of 3 GPM is often considered acceptable. A meaningful recovery rate test on a well typically costs several $100s and has to be done by a well expert. Further, many owners of rural properties will not permit recovery tests to be done on their wells because of the large volumes of water drawn off the well that may stress the well. Further, if the water out of the well is put into the septic system, this can create a stress on the septic system. In summary, you should be very careful about any conclusions you offer with respect to well performances. While it's always nice to be reassuring, you don't want to be invited back to the property to pay for a well that performs the way you said the existing one would. That was a lot to read. Type of well. So there's a dug There's called dug wells, 2 to 3 feet in diameter and about 30 feet deep. Will be more susceptible to minor changes in groundwater levels. You have bored wells, 2 to 3 feet in diameter and less than 50 feet deep, sometimes 100. Or drilled wells, 4 to 6 inches in diameter and commonly about 500 to 900 feet deep, less likely to be affected by surface contaminants and seasonal changes. And here's a picture. Here's an actual pump. Here's an actual pump that is located outside. The white hose on the left is extracting water from the ground, and the pipe on the right is bringing water inside the house. Alright, dug wells. Prone to ground surface contamination, proper grading, slope ground surface away from well at radius of 10 feet. Make top casing watertight. So dug wells are typically shallow and rarely more than 30 feet drop. Their diameter can be 2 to 3 feet, and they may be lined with brick or stone in old construction. Modern dug wells typically have precast concrete casings. These wells are vulnerable to contamination by surface water and chemicals. In modern construction, the top 8 feet of the well casings often have to have watertight joints to minimize the risk of contamination by surface water. Slope grade away. The well casing should project at least 12 inches above grade and should be sealed tightly at the top. The ground within a 10-foot radius of the well should slope down away from the well to promote surface drainage away from rather than towards the well casing. Dug wells often have very good storage characteristics. For example, a 2-foot diameter well with 10 feet of water in it forms a reservoir of roughly 200 gallons. Susceptible to water level fluctuations. Dug wells are very susceptible to minor changes in the groundwater levels. A slight decline can render the well useless. Bored wells, normally less than 50 feet, make top casing watertight. Bored wells are typically 2 to 3 feet in diameter and are usually less than 50 feet deep, although they can be up to 100 feet deep in some cases. Whoops. The depth is limited by how much excavation can be done without the walls caving in. Again, a bored well provides a good reservoir. The top 8 feet of the... Hold on, what's that? The top 8 feet of the casing joints should again be watertight for pollution protection. The top of the well casing should again be extended to at least 12 inches above the grade, 12 inches above grade, and sealed tightly at the top. Again, the surface grading around the well should slope down away from the well. Okay, drilled wells. Well casings are usually steel, although plastic, brass, copper, and fiberglass can be used. If water is acidic, plastic is better. So drilled wells are typically 4 to 6 inches in diameter and are commonly 50 feet to 900 feet drop. There are wells that are even deeper. One of the advantages of drilled wells is that they are less likely to be contaminated because the water is drawn from a much deeper source. The well casing is typically steel, although they can also be plastic, brass, copper, or fiberglass. When the water is acidic, plastic casings may be better than metal. Oop, give me a second. The wells are small in diameter, but must be large enough to handle the pump systems. Submersible pumps, for example, are lowered down into the well. Casings for drilled wells. Casings can be steel, most common plastic, brass, copper, or fiberglass. Alright. Read that 3 times now. Well casing usually goes down into the bedrock. Below this point, contamination is not a significant worry. Drilled wells usually have a casing that goes down from the top of the well into the bedrock. There's a whole sentence I didn't even read yet. Exterior of casing is normally filled with a slurry. Cement, grout, or concrete. Bentonite, etc. To seal from groundwater contamination. Anyways. Drilled wells usually have a casing that goes from the top of the well into the bedrock. Once the well is into the bedrock, the casing stops. We're not worried about contamination of the casing below this point. The fissures in the bedrock allow water to flow into the well below the casing. The casing itself is watertight, so no water should flow into the well through the casing. In some areas, only the first 20 feet or so of the well requires a casing. This will depend largely on the soil type and depth of the aquifers? Yep, never heard that word before. Sealing the casing. When the well is drilled and the casing is inserted, the space between the outside of the casing and the earth is typically filled with a slurry that is designed to seal the space. We don't want the surface to run down the outside of the well, while casing and get into the well below the casing. The slurries can be cement, grout, or concrete, bentonite or other clay slurries, or well cuttings. Wow, this is a weirdly formed sentence. The slurries can be cement, grout, or concrete, bentonite or other clay slurries, or well cuttings, or, in some cases, surface materials. Very often, the casing protection will be a combination of these. Below the depth at which you are worried about contamination of the casing. The casing may be stabilized with sand, gravel, or surface materials dropped in around the casing to stabilize it. So, static head. Drilled wells are supposed to be vented. Static head is the location between the pump intake and water level. Venting of drilled wells. Drilled wells are supposed to be vented. In some cases, the casing lid that protects above grade provides perimeter venting. In other systems, a 3/8-inch copper or galvanized steel vent pipe with a gooseneck at the top is used to vent the well. In either case, spiders and insects can get into the well and contaminate it. Ugh, disgusting. No venting. We have seen wells where no venting was visible and yet the well seemed to perform adequately. This probably varies on a case-to-case basis, but you may want to note that you couldn't find evidence of venting for a drilled well. Vents in pits or inside house. The vents for wells are sometimes completely enclosed in the well pits. Sometimes the vent line will run alongside the water supply line into the house, and a vent pipe will be visible just inside the home where the water pipe enters the house. Drainage, casing, height, gases. Well pits that are properly designed are typically drained, although you often won't know this. In a pit, the top of the well casing should be roughly 12 inches above the floor of the pit. If unpleasant well Yeah, if unpleasant well gases are a possibility, I almost said grasses, a well pit is probably not a good arrangement. Depth of pipe is an issue. If a well is drilled 200 feet deep, a submersible pipe is not put right at the bottom of the well. Similarly, an intake for a jet pipe does not go to the bottom of the well, for fear of drawing mud and other debris into the water supply. The intakes are usually several feet above the bottom of the well. For example, in a 200-foot well, the submersible pump may be only 100 feet under the water. The 100-foot depth of immersion is referred to as the static head. Components of a private water system supply: the foot valve and strainer, the suction line, the pump itself, the discharge line, a pressure tank, pump controls, house supply distribution piping. Alright. Shallow well systems up to 25 feet. Centrifugal pumps or piston pumps. Deep well systems more than 25 feet typically use centrifugal pumps. 14.7 psi atmospheric pressure can push water up above 34 feet. Due to resistance in pipes and inconsistencies, 25 feet is a practical limit. Electrically operated pumps are commonly used to provide water from wells, rivers, lakes, and cisterns to house plumbing systems. Alright, so deep wells and shallow wells. 34 feet is the theoretical limit of how much atmospheric pressure can push up water. 25 feet is the practical limit. So suction limits. Pumps and wells are often broken into shallow wells systems, 25 feet or less in depth, and deep well systems, more than 25 feet. What's magic about 25 feet? There's nothing exactly magic about 25 feet, although there is magic at about 34 feet. This is roughly the distance the atmospheric pressure can push water uphill against a vacuum. Atmospheric pressure is about 14.7 psi. 1 psi can push water up 2.31 feet. Theoretically, 14.7 psi can push water up almost 34 feet. Since pumps can't create a perfect vacuum, and because there is resistance in the piping, a practical limit of about 25 feet applies. Let's put it another way. A pump can pull water up about 25 feet. If the water is more than 25 below the pump, we're going to have to do something different. This brings us to the pump location. So, pumps. Pumps are normally located at the bottom of the well. A pump that sucks air instead of water can quickly destroy itself. 20 psi differential between cut in and cut out is considered minimum. So, pump location. The pump can be located inside the building, at the top of the well or the edge of the lake, or can be located at the bottom of the well or on the lake bottom, for instance. Pumps are much better at pushing water than pulling it. It's great if we can put the pump down in the water. The downside is we have to make the electric-powered pump watertight so it can be submerged in water. No priming needed. Another advantage to putting the pump in the well is that we don't have to worry about priming the pump. Pumps are really good at moving water, but not very good at moving air. A pump that sucks air instead of water may destroy itself pretty quickly. Priming the pump means we have water available to to the inlet side of the pump. Foot valves. Pumps that are located above the water usually have a foot valve at the bottom of the intake. The valves prevent the water draining out. So foot valves prevent water from draining out of the suction line. Types of pumps. Let pumps, submersible, centrifugal pumps, piston pumps, not shown in this picture. Pumps on shallow systems can be reciprocated, bracket piston, pumps, or centrifugal pumps. Piston pumps are older and, for the most part, have been replaced by more effective and more economical centrifugal pumps. Jet pumps and submersible pumps used on deep well systems are typically centrifugal. I'm only now on slide 18 of 64. Let's get this over with. Jet pumps. This single pipe jet pump is the most common pump used on shallow wells. Two-line jet pumps are used for deep wells. Pump creates low pressure that draws water into the pump. Pressures of 40 to 60 psi can be achieved. Centrifugal pumps. The centrifugal pump has an impeller which spins in a housing. The impeller pushes the water, speeding it up. The water is thrown into the volute, the widening passageway at the discharge side of the impeller, and the pressure behind the water is reduced. It is this low pressure that draws the water into the pump. The impeller throws the water into the volute, and the water is discharged into the piping system at reasonably high pressure. 30 to 60 psi is typical. The electric motor is directly attached to the pump. The motor shaft drives the impeller directly. There is a seal between the pump and motor shaft. Shallow well with a single jet pump. So, modern centrifugal pumps are jet pumps. Many pumps are made with 3 hose connection ports. The intake and discharge fittings are used on pumps in a shallow well situation. The intake and discharge fittings are used on pumps in a shallow well situations. No, that's how it's read. Less than 25 feet with a venturi at the pump. A second discharge fitting from the venturi is plugged in this application. You won't see the venturi connection on deep well greater than 25 feet jet pumps because it will be down near the foot valve. You will see 3 pipes instead of 2 connected to the pump. So shallow well pumps. Shallow well pumps are typically one-line pumps. They have a single suction line connected to a well. In most cases, the water within 25 feet of the surface when this type of pump is used. The well itself can be much deeper, but the water level within the well should rise up to 25 feet or closer to the surface. The ejector assembly, the portion of the pump that houses the jet/venturi and creates a suction force, is inside the pump itself. Using a shallow well pump on a deep well will most likely result in insufficient water volume, low water pressure, or no water at all. The bottom line, the water is just too deep for the pump to do the job. Shallow well pumps are very popular for watering lawns. In milder climates, it is common to see them outside. They are often drained or disconnected and stored in the winter. So here's a picture. The red arrow points to the single suction line. Okay. The blue arrow points to the pressure line. It sends the pump water to the pressure tank and the house. There is a lot of pictures coming up. Great, I like that. Here's an example of a pressure tank with a pump located just above it. Okay. Another picture. Here's a closer look at the motor. This is a single line jet pump, and because of its smaller size, the well is likely more shallow. I look at these pictures, I don't even know what I'm looking at. I just see blue containers and pipes. Another picture. Because the water from this well is cold, the water level is clearly visible on this tank. Okay, yeah, I can see that. It's more dirty looking than actual condensation. There is a good air cushion inside. When the air cushion is lost, the water level will rise. So deep well pumps. Jet pumps use venturi. This is a narrow spot in the pipe where water has to speed up. Two-line jet pumps have 3 pipes attached to them. So piston pump. Older pump system do not have large circular volute casing that you find on centrifugal pumps. Identifying piston pumps. Piston pumps have a piston in a cylinder like... What? Piston pumps have a piston in a cylinder like an automobile engine. They are easy to identify because they do not have the large circular volute casing that you find on a centrifugal pump. Many old piston pumps also have a motor that drives the pump via a belt and pulleys. Centrifugal pumps are not belt driven. Anyways, pumps. Pump characteristic curves can provide information on performance. Pumps can be designed to move large volumes of water in low pressure or provide high pressure and low volume. Generally, pumps need to move 3 to 5 GPM within a pressure of 30 to 60 psi. How much work can a pump do? Why is Tornadus taking so long? Pumps have characteristic curves and profiles of performance. With no flow, they will be able to develop a certain pressure. As the pump moves more water, the pressure will drop. The performance curve for a pump shows how the pressure drops as the flow increases over the working range of the pump. Pumps can be made to deliver very high pressure and low volume. Pumps can also be designed that will not develop much pressure, but will move large volumes of water. Residential water supply pumps generally need to move 3 to 5 gallons per minute within a pressure range of 30 to 60 psi. Oh boy, there's a slide coming up with a lot to read. Pumps. Some terms. Total head is the capacity of developing a total pressure. Suction head, pause, is amount of work done on the intake side. Discharge head, geez, who named these? Is the amount of work done on the outlet side. Alright, suction head and discharge head. Super suck deluxe. Anyways, so suction head and discharge head. Another term for pressure when we're talking about pumps is head. Nope, hello. We're just talking about suction heads and discharge heads. A pump is capable of developing a given total pressure, or total head. A lift pump may do quite a bit of work to pick the water up on the suction side of the pump. This leaves only so much energy left to push the water out of the discharge side of the pump. The amount of work done on the intake side is called the suction head. The amount of work done on the outlet side is called the discharge head. The suction head plus the discharge head is the total head. And there's a very, well, there's a diagram here. Drilled well with submersible pumps. Are we talking about pipes? No, now we're talking about wells. I just finished week 1's material, now I'm on week 2. Should Venturi be at the top or bottom of well? Some people say it's better to put the Venturi at the bottom of the well so that more of the work done by the pump can be on the outlet side so that we can push the water up to the top of the well. It really doesn't matter. Let's assume we need to raise the water 20 feet from the well to the house. The top of the well is 10 feet above the well water and 10 feet below the house. If you put the pump and Venturi at the top of the well, assuming a shallow well, the pump will be pumping the water up 10 feet on the inlet side and pushing water up 10 feet on the discharge side. The total head is 20 feet. Wells, you're moving up in the world. It doesn't feel like it. If the Venturi is on the well, it has to push the water up 20 feet on the discharge side. The total head is still 20 feet. Whether the pump is pushing or pulling, the water is still raised the same height. Oh boy, there's a lot to read on this one. Pumps. Submerged pumps work better because pumps are better at pushing water than pulling water. Submersible pumps must have the electric motors submerged. Cut in and cut out of 40 to 60 psi. Pump sizes can range between 1/2 horsepower to 3/4 and 3/4 and 1 horsepower. That is a strange way of phrasing it. Most pumps are better at pushing than pulling. The disadvantage to putting the pump and Venturi at the top of the well is that most pumps are better at pushing water than pulling water. Pulling water depends on negative pressure, which involves suction, maintaining primes, and running the risk of drawing air instead of water. The other side of the coin is that pumps that are submerged in the water with their electric motors also submerged, have to be watertight. Electric motors don't like water in them. Servicing and maintenance is also more of a nuisance if the pump is underwater. Submersibles work well. The way things have evolved, submersible pumps have been successfully designed, and although they are more expensive, they are good performers. Some submersible pumps have a low water level cut out, which protects the pump in the event that the well runs dry. I'm better at pushing than pulling, aren't we all? Pump quality. Better quality pumps have brass or bronze internal mechanisms. Lower quality pumps typically have brass or plastic internals and plastic casings. High quality jet pump casings are cast iron, and high quality submersible pump casings are stainless steel. Our focus. We're not supposed to be pump service technicians or troubleshooters. We're going to test the plumbing system and make sure the water is delivered at reasonable pressure and volume at all of the fixtures. There will be much of the system we can't see. For example, you're not going to be able to see the foot valve and strainer. You're also not going to be able to see some or most of the suction or discharge piping. Pause on that. Depending on where the pipe's located. Let's look at let's look at some of the common pump problems we come across. Pump conditions: inoperable, leaking, excess noise or vibration, wiring problems, short cycling, running continuously, rust, damage, freezing, overheating. Pressure tanks. Pressure tanks serve to deliver water at a relatively consistent pressure to fixtures. If no tank is available, pump will experience many on-off cycles and can have reduced life expectancy. Excuse me. Sizes may vary between 10 to 60 gallons. Two types, bladder or diaphragm. Are we talking about the same thing anymore? Pressure tanks. Function. The function of the pressure tank, also called the hydropneumatic, that's a big word, took me a second, also called the hydropneumatic tank, cushion tank, compression tank, or expression tank, is to deliver water at a relatively consistent pressure to the house fixture. What would happen if there were no tank? The pump would short cycle. Since water is not compressible, the pump will build up pressure in the system with all the faucets closed, and the pump will shut off at its cutoff point. As soon as a teaspoon of water is released through a faucet, the pump will come on. If the rate of flow at the faucet is lower than the pump discharge capacity, the pump will immediately build up pressure again, and the pump will shut off as it reaches the cutoff pressure. However, if the tap is still open, another teaspoon of water will be drawn off, and the pump will cut in again on the low pressure switch. The pump will continue to come on and off quickly, which is very hard on the pump and may deliver a pulsating water pressure at all the fixtures. At the fixtures. Still a lot to read. Pressure tank components and pump controls. Air acts as a spring, air pressure, to push water out as it gets compressed in the tank. Air can eventually dissolve, and tank will become waterlogged. Tanks may be insulated to prevent sweating in humid days, cold water from rivers or wells. So, coiled spring. The pressure tank is like a spring. It is typically filled with air when the system is first filled with water. As the water enters the distribution system, singular, it practically fills the expression tank. Air is quite compressible and acts like a spring. The pump compresses the air, which squeezes the spring. When the water in the system is fully charged, the tank will be practically filled with water and practically filled with air. As the first faucet is opened and the first small amount of water is released, the air in the tank will expand and push the water out through the piping system. When the pump When the pump would you work on one of these? Would you work on one of those oil rig pipes? Hell no. You know what? Now that I'm actually doing this, I really question, why didn't I just take on cooking? When the pipe shuts off and water is drained from the systems at air pressure, pushes the water out and the air expands as the water leaves the system. Gets sucked in completely. The expression of the air in the tank creates a slow drop in pressure and can take up to a minute for the pump to kick on. This depends on the rate of flow, the size of the pressure tank, and the cut in and cut out settings on the pump. This arrangement is much easier on the pump and its motor and delivers more uniform water pressure throughout the house. Pipe engineer is way cooler. Well, not in my position, not from where I'm sitting. You know why I took this? Like, what one of my thought processes was? This is one of the jobs that cannot be replaced by AI, at least not anytime soon. You know, my mom loves showing me these WeChat shorts where even in Asia, they just straight up have machines cook food. I mean, the dude's job is just to put in the food and then the machine cooks it all. You know, service workers like waiters, waitresses, what have you will be replaced by AI soon. I've seen it already. Doctors, I'm sure, will be replaced at some point, but these kind of jobs, not anytime soon. Anyways, so another picture. Here's a pressure tank located in the house. You can see the picture, the pressure relief valve, the pressure gauge, and the pressure switch which operates the pump, and the main water shutoff valve. Nothing is labeled on the picture. Bladder type pressure tank. Bladder types will prevent waterlogged situations. So, tank types. The pressure tanks may be similar tanks. What? The pressure tanks may be simple tanks, or they may have a bladder or diaphragm that separates the water from the air. The air in a simple tank will eventually be dissolved into the water, and the tank will become waterlogged over time. The rubber bladder or diaphragm prevents the air from being dissolved into the water, and the tank will not become waterlogged. W homework stream. I promise to not be rambunctious so you can do your homework. This isn't even homework, this is just me going over the course material. Because I have a paper due tomorrow. Paper due tomorrow, and I'm doing the material now. Have I learned nothing in life? That is correct. Pressure tanks. Conditions. Rust. Leaking. Condensation. Waterlogged. Tank unstable. Waterlogged pressure tank. Short cycling. Yada yada yada. A big diagram with a lot of words. Waterlogged tanks will cause a pump to short cycle and burn itself. Condensation on entire tank can identify a tank being waterlogged. So, waterlogged. The air in the expression tank may be entirely dissolved into the water. The tank is then filled with water. A waterlogged tank will not do its job. Causes. This happens naturally over time, and it is not unusual to have to drain and recharge a tank with air every year or so. Bladder tanks should not require recharging unless the bladder has failed. Implications. A waterlogged tank will cause a pump to short cycle and burn itself out prematurely. I almost said permanently. Strategy. When the faucets in the house are opened and the system is operating, watch for short cycling at the pump. This often indicates a waterlogged expansion tank. Another clue that the tank may be waterlogged is condensation over the entire surface of the tank. Why can't Tornadus just be shiny? It has been so long. I have 2 more things to hunt. This is an old cast iron piston pump, a very dirty picture right here. The blue cylinder is the motor, and you can see the shaft not attached to the pulley. On the left is the pump head, which contains the piston. These pumps create high pressures but relatively low flow. Point out the inlet and the outlet. Literally just arrows pointing to some very dirty pictures. They couldn't find clean pictures for these things? Like, geez, every picture is dirty. Another picture of whatever I'm looking at. This is a relatively modern jet pump set up for shallow use because the injector is at the pump on the top right corner. In the picture, the top right corner, all I'm seeing is a door. The water enters the pump through the venturi on the right into the expansion tank from the green hose and to the house supply plumbing from the expansion tank at the bottom right. The black pressure gauge is on the top connected to the pressure controller. The expansion tank below supports the pump. The bottom left is an automatic air makeup to prevent logging of the tank. Why is this hunt taking so long? He's APL to... What? I don't even know what you said, man. Another picture that almost looks... actually looks the exact same as the previous one, just from a different angle. The steel box on top is the priming port. The steel... It actually says that. The steel nipple on the left is the manual regulator. This adjusts the pump's back pressure so the venturi works properly. I stole that joke from someone else and it was funny when they said it. Oh, so you didn't misspell stuff in that. Why is this hunt taking so long? He's apple to piston anything. That's his stow. Yeah, I don't get it. I'm sorry. And now there's something that looks like it should be out of a hospital. This is a close-up of the air makeup for the expansion tank. It's something orange. It almost looks like an IV bag, although it's more solid. And I don't even know what I'm looking at here. It kind of looks like something out of, I don't know, Garden of Banban. This is the converter venturi for a shallow jet pump. Water is discharged out of the pump into the bottom hole. The water is turned 180 deg, literally just says deg, and is squeezed through the upper hole. The water comes back with high velocity. Some of the water is directed to the house, and the rest is recycled back to create more suction. In a jet pump, 3/4 of the water is fed back to the venturi. What's a deg? Well, I'm sure it says degree. The water is turned 180 degrees. What's funny about these two slides is that the background is the exact same. So whatever I'm looking at here is just a PNG put over what looks like a sandpaper background. Because every detail of the background is the exact same. This is another Venturi. You can see the small opening in the suction hole. Ooh, at least this one's going by faster than week 1's material. I'm already on slide 44 of 64. Something that looks like... whatever I'm looking at looks like it's coming out of Star Wars. Legit. This is a plastic Venturi. It goes inside a pump in a shallow vent. Water flows from a well into the center. The right side allows water from the pump discharge, and water enters the pump and the supply plumbing from the left discharge. Alright, some other picture. Lots of pictures. Yay, that means less things for me to read. An actual like visual reference too. Even though majority of the time I don't know what I'm even looking at. This is an older jet pump set up for deep well application. There is 2 pipes on the right because the Venturi is in the wall. The suction pipe brings water into the pipe, and the other takes water from the discharge side down into the well. The water is accelerated through the Venturi, which creates suction and draws water up to the pump. Top pipe brings water to the supply plumbing. Lower left corner box is the pressure controller. And then there's some sort of label with a bunch of gibberish on it. Here is a sample data plate identifying dates, voltage, HP, RPM, etc. Well, even if you told me what the etc. is, I wouldn't understand what it meant. So thanks for that. Alright, another picture. Here is another jet pump with cast iron housing. And something that looks like one of the cookies out of Squid Game. This is an impeller for a jet pump. It actually just looks like one of those cookies. This is a submersible pump around 4 feet thick. Unless that is inches, whatever. Maybe that is. These can create greater volume and pressure because all the water going through the pump is there for use. In a jet pump, up to 3/4 of the discharge water is fed back to the Venturi. Grundfos. That's what's written on the box. Some sort of shoe box in the picture. This is another submersible pump. This is a foot valve for a cistern or dug well. Just looks like a spark plug. Something... did they edit this picture? It's literally glowing. It has a very 90s style glow to it. Some sort of like yellow spiral spring with a red glow on it. It looks like they just edited this picture. This is a pressure regulator. The spring is contact trigger, which will turn the pump on or off. Is the submersible pump cast iron? You're asking the wrong person. A lot of the info I'm reading, I'm just saying out loud, but it's not registering. This is a foot valve for a drilled well. It is less than 3 inches in diameter. I'm going to assume that's inches. Another picture. Here is a more modern jet pump. I'm noticing a lot of these pictures that depict a jet pump, they're always blue. Always this bluish green color. The pump controller is mounted on the bottom right side. Okay. Identify the regulator and the pressure gauge. I will not. This is a jet pump with the typical black polyethanol line. The 2 cylinders on the horizontal line are filter systems. Okay, I'll save my questions for when you're a pipe expert. I'm already a pipe expert, if you catch my drift, just not for anything I'm currently reading. There are 2 pumps here. One is from a lake, and the other pump is from a well. Both pumps have bladder-type expansion tanks. Again, they're both blue. On the left is a centrifugal pump, and on the right is a piston pump. We're going through these slides very quickly. I like that. Some sort of rusted tin can. This is a large expansion tank. The water enters from the left pipe and gets supplied to the copper plumbing. They can't take any of these pictures when the material's new. All of these pictures are dirty as hell. You can't take the pictures when the material's brand new before the rusting happens? What specialty of pipe are you an expert in? I'll leave that up to the viewer's interpretation. At the bottom, you have a pressure controller and a gauge. Notice there is oil in the gauge to prevent water leaks from damaging the gauge. Oh my, this is the dirtiest pictures I've seen yet. Here's an expansion tank with the pressure controller. Notice a condensation on the tank from the cold water inside. That's not what I noticed. I'll tell you what, I saw this picture. That condensation's not the first thing I noticed. This is a smaller bladder type expansion tank. Cool. Oh no, there's more to read here. Thankfully, this looks like it's going to be the last slide with a substantial amount to read. Personally, I'm very knowledgeable in fiberglass commercial slump pumps. Well, neat. Very cool to hear that. Maybe what I'm saying sounds like gibberish to you, since I'm only now diving into this world. Anyways, case studies. For our case study, act as though you are doing the inspection. Look at the component or system or condition. State what the component is, state the condition or deficiency, state the implication of the client, for the client, state what you will recommend as a course of action. See, this is the slide for the professors. When they're done teaching the material, they will turn to the student. They will show pictures and expect students to raise their hands and say what they just learned. Me, on the other hand, I'm always the guy who just avoids eye contact and really hopes the professor doesn't pick me. Anyways, alright. Try to mimic a real inspection. Get used to what the standards require you to tell your client. Use the 4 steps process. State the component. State the deficiency or condition. Wow, this third one, steps 3 and 4 are huge. Step 1 is just state the component. Step 2 is state the deficiency or concern. Step 3, state the implication for the client. How will affect the client. For example, oh, never mind. It's just an example. I saw a lot of words and I just assumed. For example, it would cost lots of money. Will it be an area that needs attention constantly? Will it be dangerous if they don't fix it? Or is it just not ideal but typical on most houses? It is easy to become a perfectionist when you're criticizing homes, but our job is to put things into perspective. Take some time to explain this concept. Alright, that was step 3. You know enough about pipes for the professor. State your recommended course of action. This is not a repair protocol, but rather, what should the client do next? Further evaluation by a structural engineer, which I very much am not. Call a contractor for quotes on repairs. Monitor it over the years. Don't forget that if you ask a client to monitor a situation, you need to tell them the possible outcomes, bracket implications. Okay, here's a picture of a very dirty, rusted container. Case study 1, component, expansion tank, condition, rusted, implication, could fail, allowing water and or air to escape. Man, that looks like it's gonna start a plague is what I'm saying. Recommendations. Recommend replacing the expansion tank. You should have been replaced that. From what I see, that should have been replaced yesterday. This equipment tank is completely rusted out. Really? You don't say. I swear to God, I do house inspections. I see this. Man, I'm about to be fired because I'm really going to let the client have it. Alright, another very dirty looking picture. This tank is inside the wall and only the far end is visible. The right copper pipe with the valve is supply into the house. The middle arrangement is a sight glass to view the level of the water. I don't even know what that means. The picture does nothing for that. And final slide. This is a activated carbon fiber placed downstream of the pump to remove suspended particles. Whatever this thing I'm looking at is. It kind of just looks like a water bottle. Okay, there you go. Week 2's material done in like an hour and 10 minutes. Great, now I get to relax, stress for the rest of the night, and tomorrow I have one day to do my paper and hand it in. You guys ever been through that school phase where you don't even care if what you did... Oops, how long has this been tilted? You don't even care how good you did it, you just want to be done and hand it in. You don't care if you get a crappy mark, you just care that it's done and you handed it in. Life is all dandy. Well, that's me. That was me for a very long time, and that's still me. I don't care how good I do this paper, I just want it done and handed in. Wait, you said you weren't absorbing any of it, how are you done? Because I said I'm done, and I don't want to think about it anymore. Yee. I got more worrying things to worry about. Like how tomorrow morning, starting at 7 a.m., there's supposedly a big winter storm happening. Great, I gotta wake up early tomorrow to shovel the snow. Alright, so I just sped ran through 2 weeks worth of materials. Thank God this thing does not have any quizzes. It does have a midterm. Maybe having knowledge on cast iron and PVC pipes will help you in the storm. The only knowledge I have of cast iron is how good it is to cook. I really should have just took up cooking. You know why I didn't want to take up cooking? Why I didn't want to become a chef? Not because of the whole AI thing I just said. You see, I like to cook food. I cook dinner at home. I cook all the time. The reason I don't want to take up cooking for school is just because, well, one, I would have to go through the entire process again about learning about food. It doesn't matter if I've already learned it in high school or not. I have to take it again. So it would be health, safety, nutrition, all that stuff. I would also have to probably learn about agriculture, farms, how crops are grown, how livestock are raised. I probably have to learn about that stuff as well. And I'm just here to learn to cook, people. And then finally, after all of that useless nonsense, I can finally stand in front of a stove and prepare something. But then again, that's another reason I don't want to go to school for cooking. See, when I'm at home and I'm cooking dinner, I control the portions, I control the ingredients. And more importantly, there's no time limit. See, I've done the whole cooking under a time limit thing before. It's not great. You're stressed, everything has to be perfect, and if your dish isn't prepared when the time limit's over, well, screw you. And when you're at home, how often are you cooking dinner to the point you have to tell them dinner's not done yet? Just wait a bit. Nobody's gonna complain. Right? So I don't want to go to school for cooking. I'd rather just cook at home, on my own. And it's not, when you think about going to school for cooking, I'm sure some may assume it's just like, well, you go and learn recipes in person. Perhaps, but you know what? That's what the internet is for. What if your pipe knowledge will make you a Michelin star chef? I don't even want to be that, to be honest. If I were to take up cooking professionally, I don't even want to be a Michelin star chef. You know how much pressure that is? You have one shot to You have one shot to handle these high quality ingredients, which are a puny proportion. I don't want to do that. If I had my own place, I would make myself... Wait, that's not right. If I had my own place, I would make, comfort food. Something simple. Kind of like a diner or a cafe. Simple, easy food. Comfort food. Not that high class crap that you pay an arm and a leg and you don't even feel full afterwards. You learn more technique than recipes. But yeah, I don't want to do cooking. And also, my dad has been pestering me a lot to take up... Geez, why can't I think of the word? Oh, yeah. Take up chiropractoring. Hell no. I do not want to take chiropractoring. Because, like I said, kind of like with cooking, but that's worse. Chiropractoring, that has to deal with health, the body. So I have to study about the human body, and that alone is a huge topic I don't want to do. And then chiropractoring, if I screw up something, that's a lawsuit on my hands. No thank you. And that's also another thing, another reason I don't want to go into cooking. If I cook and I make someone sick, I am screwed. Contaminated ingredients or what have you, an allergic reaction I didn't know about. If something happens, I am screwed. I do not want that. So I do not want to go take up cooking for a course. I've actually considered starting a cooking channel, kind of like Zach Choi or the other guys, just cooking shorts. I've considered that. I'm just lazy. If I wasn't fat and lazy, I would absolutely have done it by now. Do a cooking stream. Well, I honestly could, but I might actually need a cameraman for that. Have you seen how botched it looks if it's just me holding the camera and trying to cook? That's not only not very pleasant to look, it's also not safe. Especially when I'm handling the knife. You know, I don't know why someone like my sister really can't figure out cooking. It's easy. Like, actually. Cooking is relatively simple and straightforward. You honestly don't need to be taught. For the most part. Anyway, so there's other things people have suggested to me that I maybe take up. But it's very, very, very simple why those ideas fall flat. You know, my parents say I'm in front of the computer all day, so why don't you take something computer-wise, programming-wise? Yeah, I don't know the first thing about programming. I don't know the first thing about computers. Don't ask me what a RAM is. I have no clue. I am not exaggerating when I tell you I know nothing about computers. The only thing I know is how to turn it on. I really know absolutely nothing. You can ask me any component, I will have zero clue what kind of language you're speaking. Like, honestly, I'm not exaggerating. I know zero about computers. The computer I have now, my friend bought it for me. Because otherwise, yeah. So that's out of the question. Well, I'm also told, I'm also suggested you're a gamer. You game a lot. Why don't you go into gaming? It's like, I don't think you understand what that means. Because I know nothing about game programming. And the chances of me getting like a play tester where I play the game and get paid for it, that's pretty slim. And I'm not playing the game for the sake of enjoying it. No, I'm playing the game to test play it. Make sure it doesn't break, there's no bugs. Like, I'm not playing it for the sake of enjoyment. I'm actually testing it. And I need to report back any issues I find. And if I don't do my job, the game comes out in a garbage state that needs working, the fandom is pissed off, the company loses money and faith. Yeah, guess who's getting fired first? So that's an easy no. My parents suggest I maybe take up car salesman alongside one of our other friends, and it's just like, First of all, already being in sales makes me want to blow my brains out. And second, damn, imagine me, the guy that becomes that stereotypical, car salesman who preys on your weakness and finds every way to get you to buy. Yeah, no thank you. Another thing that my parents, mainly my dad, suggests that I actually was considering, and I might still do, I don't know yet, is real estate. Just because my family has a lot of real estate friends, they can help me along the way, and then once I finish the school program, they can just take me in. But by no means is it easy. Then again, what is easy in this world? So, maybe. But, of course, my dad, he's just like, son, if you're gonna do real estate, why don't you throw in interior design as well? As if throwing in a whole different subject is easy, regardless of if it relates or not. Because it's like, son, if you do real estate, you can also offer them, hey, if you're going to buy this house, I also do interior design. I can help you with that as well. Boom, double paycheck. Yeah, as if it's very easy, to just throw in another occupation on the side. Truth nuke number 2. I have all this, I have the pressure of school, the pressure of finding a job, and now on top of all of this, the pressure of getting married before my grandfather dies, as well as giving my parents a grandkid. Yay! And people question how you don't lose your sanity in this world. Wait, why do you have to get married before your grandfather dies? Because my grandfather would like to be alive to see his grandson marry. My grandfather's from a different age, given the fact that he's my grandfather. My sister got married, sure, but doesn't really care about that. He only cares if his grandson gets married. And his only other grandson, to my knowledge, he's just started high school, so he's not getting married anytime soon. And you know what? I admit, I would like to marry while my grandparents are still here. Well, 2 of them are still here, and one probably won't make it, like physically make it here, because she's on the other side of the planet. And traveling at that age just is a no. So I'm not gonna lie, I too would like to marry while grandparents are still here. But, I actually don't know if my dad's other brother has a son or not. I don't think so. Otherwise, I would have heard of him at least. I know he has a daughter, which I assume maybe died, because I've never heard from her ever since. I don't know what happened to her. She lived with us for a little bit, like 15 years ago, and then she just left. No one knows where she is. Every time I ask about her, everyone just brushes me off, like, don't worry about her. So I don't know. She could be alive and dandy somewhere out there, or she could be dead, and I don't know. All these years, I've just assumed she's dead. Speaking of which, I never knew all the details about my family, let's say, tragedies. I do have relatives that I never met just because they were dead before even my parents were born. I didn't know my grandparents had a lot of kids, and can you believe on both sides, a couple of them didn't make it? On my mom's side, what I just recently learned, my grandparents' first kid didn't last like a week. It was a different time back then. And then I forget what my mom said. I think their second child is still alive, but then the third one didn't make it. I'm not too sure what she said. Like, let me think. That means my grandparents had 6 kids, 2 of which didn't make it. And back then was a different time. Let's say my grandparents, they started having kids pretty young, around the 20 age mark. And geez, look at me. Well, whatever. I finished the school materials. I'm going to game the rest of the night. Not like there's very much of the night left, because we're 6 minutes away from midnight. So I'm gonna game whatever is left of the night, and then I'm gonna go to bed, be stressed about the paper I have to do tomorrow. I mean, it shouldn't be that bad, you know? It's just a quick little paper that I have to type up. You know, it's not like I have to do extensive research. Oh no, my dreams have come true. All these years of nightmares thinking of the fact that I got an assignment coming up that I haven't even started yet. It's true. It's come true. I do have an assignment due tomorrow, and I haven't even started on it yet. My nightmares have come true. You know, once I'm done this class, let's see how much longer these nightmares persist. The fact that I keep dreaming about the fact that I have some sort of school assignment coming up, which I haven't even started on yet, they happen all the time. Like, a couple weeks ago, I had a dream where I was in 8th grade and I had a semester-long assignment due, and it's just like, wait. I woke up, wait a second, I'm not in 8th grade anymore. I graduated not only high school, but also college. I don't have no damn assignment. Well, now I do. Anyways, I'm gonna end this in like 5 minutes. Is it cold for anyone else? Obviously, it is frigid over here in Canada. I'm hearing other parts of the world are finding it cold too. Oh shit, hold on. Give me a second. Okay, I'm back. Ugh. Alright, folks, I'm about to end. Hopefully I can structure these better where I'm not only going over schoolwork, but also going over some shows as well, because I would like to watch some TV. Okay, one last encounter and then I'll call it. Wait, no. Wait, hold on. Wait, not yet. Hold on. I don't know what I'm doing anymore. Shiny Tornadus really doesn't want to show up. Okay, now will be one last encounter. How close are you to a new PB? What is a PB? Personal best as a new record? I don't know, like 5 times a day? Alright, I'll see you guys next time.